Now go with this. If a water drop is kept between two glass plates, then its shape is going to be.
Sir, you kept one number there.
I don't know. If you get this question in exam, I don't know. What will you do? If the water drop is kept between two glass plates, you have to resolve that.
Yes.
You got it? You think of different.
Sir, like practically, can this is if you have actually done this?
You think, you figure out. See, this, some mechanism, you evolve some mechanism for this. You evolve some mechanism for this.
Yeah. Sure.
Yes.
I'm taking a glass plate. I've put one water drop on it.
Good.
Now, sir, I'm taking another glass plate. And that also I put a water drop.
Good.
And both I'm keeping it, sir.
Yes.
At that point, sir, it will be like a grip only, sir. Only the other two top of the drops which are coming in contact, they will coalesce.
Correct.
And we'll get this option C.
Excellent. That's a good thinking. That's a very good thinking. Mr. Arun, see, if you always, with this enthusiasm, because in some classes you are very enthusiastic, some classes you are not enthusiastic. If you maintain that enthusiasm and passion throughout, you will be a winner. No doubt. Yes, what he thought is perfectly correct. So, in fact, I also thought like that. Okay. So, you have a glass plate and then you take a drop. Okay. You take the water and you take a drop. And this is what your friend said. You take another glass plate and you take another drop. Okay. Now you bring these two plates close. Then you are given in this figure. Obviously. Okay. That's the right thing. Because anyways, see, the best way is if you take the angle here, if you draw the angle here. So this angle, see, the angle you have to draw it within the liquid, isn't it? The angle of contact. And the angle of contact, see, they have told very clearly water and glass, the angle of contact theta must be less. Okay, less than 90. So obviously you will have to draw it like this. Here it doesn't suffice. Here the angle of, see, if you draw the angle of contact through it, it will be more than 90. This angle will be more than 90. So this cannot happen. And this of course cannot happen. And this is the positive. So C is the option. So both ways I have told you how to handle this problem.
Yes.
Correct?
Correct, yes.
Come on. So you see, I am just concentrating on the science behind this. I am not just concentrating on the options, right? And I have just taken these numericals with only answer keys. No solution is given. Okay, so I am enjoying the thrill of solving these problems along with you. Okay? And you should also choose problems like this, right? Then only you will learn. And friends, you should all meet together, discuss. Learning will happen. Right? That's coated capillary which is equal, the water in it will, yes. So for those of you don't know anything about this, start with whatever is given in the textbook. So if you had taken a drop of water, okay, and if you had dipped a glass capillary tube, okay, then you would have got the water surface like this. correct? We have got the water surface like this. If it is glass, but now they are coated with wax. So wax and water will not wax. If you are coated with that, it will not wet it. Correct? It will not wet it. Then the meniscus should be what? It should be obtuse, or the meniscus should be in this. The meniscus is down concave. In that it is going to be convex. And if the convex meniscus, they are given that example in the in your textbook. But they have taken what? Glass with mercury. And for mercury in the textbook it is given. With mercury, if you introduce a tube here, the mercury meniscus will be like this.
Yes.
I hope you remember this. Again you see from NCERT. Because why? Mercury will not wet the glass. So it will be depressed. So B is the option. Okay?
Yes.
I am pointing to you, all the answers are in NCERT. I am doing my best to encourage my students to learn science and enjoy NCERT. And it's very simple. Anybody can learn and everybody can be successful. Whosoever takes passionate and who learns properly, you can also be successful. You don't have to be under any sort of tension. Water rises to a height h in a capillary on the surface of Earth, on the surface of Moon. Okay, again here, you should know the basic derivation for this. So if you don't remember the formula, in fact I don't remember the formula, most of the formulas. Basics only I remember. So I go with this to solve this problem. Then I will have the meniscus like this. Right? So the radius of this is r. Now what is the theory here? Other day we have discussed the theory. The tension, surface tension forces will be like this. Correct? And this will make some angle theta. Okay, so therefore the total upward force, see this total upward force. The total upward force will be T the total upward force will be T cos theta, okay, T cos theta into 2 pi, the radius, T into the line. I suppose you got this. Hello? This is the total upward force. This will be equal to the mass of the liquid here. The mass of the liquid here. Okay? Into G. Okay? Into G. Now supposing the density of the liquid is given, mass you convert it into density, in terms of density. So this will be area. Area will be pi r square. Okay? Into height h. Okay? Into G. The basic formula. Okay? So here you go on knocking off 1r, then you will be left with the height to which it will rise. It will be 2t cos theta divided by rho g r. Okay? Dear students, see, this is how you have to enjoy learning physics. So otherwise, which formula should I use? फॉर्मूला देखो लगा लो, फॉर्मूला डालो, आंसर आएगा. अगर एग्जामिनेशन ऐसा होता है कि फाइनल एग्जामिनेशन कुछ भी करो तो थोड़ा टेंशन होता है. Some students at least will be fully tensed. Okay, so therefore all the students who have learned physics, okay, maybe in the tension I don't remember the formula. I should be able to do it because just use the basics. Okay, right, you get this. Now what happens on the surface of Moon? So the G will be G by 6, isn't it? G will be G by 6, and therefore the height will become 6h on the surface of Moon. So 6h is an option? Yes, 6h is an option. Continue. Clear?
Yes, sir.
So 29, the option is A. Correct. You got the K option. Okay friends, did you get it?
Yes.
So this is how you should learn to solve the problems. Not by having the formulas, or I will write the formula, you use this formula and say that is not at all the way to learn. And that is not going to give you anything. So just aram se learn like this. All derivations, everything you keep using it in every formula. You keep deriving it in everything. So all the 30 chapters, you see 30 chapters in physics. So many formulas are there. So many sub formulas are there. You will go mad if you try to by heart all of them. Basics you learn and go happily to the execution. Two capillary tubes of same diameter are put vertically, one into liquid whose relative densities are so and so, tensions are so and so, ratio of the rest. So whatever derivation I did, you can use that, or if you don't remember, you can derive it once again and do it. Come on, take some 5 minutes and solve this. Two different liquids. So you be careful, two different liquids. So just now we have derived the formula. H is equal to 2t cos theta by rho g r. General formula we have derived. Hello? So same way put vertically in two different liquids and surface tension. So here now what happens? You will get here H1 will be equal to 2T1. Why? Because liquids are different, surface tension will be different. Right? Hello? Now here we are taking one small approximation. Theta is very small, so for all practical purpose you can take theta to be 0. So this will approximate to be equal to rho gr. Okay, so you can write it directly like this, and the density becomes rho. G is same, and same tubes of same diameter. So same diameter, you can keep the R as it is, and H2 will be equal to 2 into divided by rho to G. So now they are asking the ratio of the heights. So H1 upon H2 will be equal to T1 upon T2 into the rows will be 1. Rho 2 upon rho. So just write say the units are all, don't bother about units because they are ratios, they are going to get cancelled one by the other. So this will be 60 by 50 and this will be rho 2 by rho 1. 0.6 by 0.2. 0.6 by 0.2. Okay, so this you can jolly well write it as 6 into 6 by 5 into 8. Okay, so
9 madam.
So 6 6 are 36. So 8 how much is that? 8
9 madam.
9 by 5.
9 by 2.
Okay, 2 3s are 2 4s are 2 3s are 2 4s. So here you get 9 by 5.
Yes.
There is an option and then yes. Basically. So again you see they test you with different things, and you should if you know the science in the mechanism you should not be different. Okay, shall I go ahead, students?
Yes.
A vertical 30-meter long cavity is dipped in water. The water rises up to a height of 10 cm due to the free falling elevator.
So, sir, I have a doubt.
Yes, please ask.
Sir, meniscus, sir, it can be also between two slabs that you asked.
Yes, correct.
That can also be meniscus.
Pardon?
That can also be called as meniscus.
Correct. See, only thing is now you have got two slabs, no? So this will be the two ends of the tube. That's it. See, the tube you have got it horizontal. That's it.
Okay.
Okay. Yeah. So solve this problem. 30 centimeters long, the water rises up right actually. This experiment is conducted free falling elevator. The length of the water. So again here, H is equal to 2T by rho G R. So in a particular elevator experiment, it will be up to 30 centimeters. Okay, if the experiment is conducted in free falling elevator, the length of the water column dipped in water rise up to 10 centimeters. So the height to which it will rise is 10 centimeters and the length of the tube is 30 centimeters. Okay, this is when G is 10 meters per second. Okay. Now in a free falling elevator, what happens? Now the important thing is, now understand, see, when you get a question like this, you go to the grassroots, go to the basics. Now what happens in a capillary tube? What is that? What is the mechanism that is taking place? As all of you know, it is the adhesive forces between the glass and the water that is pulling the water up. Okay, these adhesive forces are the one responsible for the net resultant force, and that is what is pulling it. And this is what is pulling it. What is it pulling? It is pulling this much column of the liquid. Correct? This much column of the liquid. Which much? This much column of the liquid. And this much column of the liquid has got what? The mass of this is this, and the weight of this is this. That means this much quantity of liquid is pulled by gravitational force, and this adhesive forces, okay, in combination with the cohesive forces, is pulling it up. That is the basic thing. Now what happens in an elevator? In an elevator which is freely falling, okay, as all of you know, see, we have done this thing with the weighing machine and all. Supposing you are standing on the weighing machine, okay, and you are watching your weight is m into g. Now if the weighing machine is going up with acceleration a, then it will show larger weight. I think all of you know it is m into g plus a. And if your elevator is going down with acceleration a, then the weighing machine will show this reading. I suppose all of you know. And if now the elevator is going down free fall, then there is weightlessness. Okay, so this becomes what? M into G minus G, that is 0, weightlessness. So here you see this liquid which is under this will not be pulled, it is weightlessness. Okay, and therefore what happens? This force will start pulling the water up. So this tube which is 30 centimeters, right? This is 30 centimeters, and what we have done is we have taken water up to this level. And now what has happened? The water has gone up to this level. How much level? 10 centimeters. Understood? Hello? 10 centimeters. That is on the surface of Earth. On Earth. Dipped. Just dip madani. Kansvoltena. Hello? Pura ek madbeka. ಸ್ವಲ್ಪ ಮಾಡಿದ್ರು ಸಾಕು. Pura dip ಮಾಡಕಂತಿಲ್ಲ. But air gap ಇರಲಿಕ್ಕೆ ಸಾಕು. No, I have a reason to show like this. I have a reason to show like this. This height of the tube is 30 centimeters. This is 10 centimeters. You will understand. Okay, got it, friends? Hello?
Yes.
Now, this is what is happening on the surface of Earth. Now, if it is taken in a lift, okay, which is free falling, then this becomes weightless. And therefore, this force will be there. The surface tension forces will be there, and because of that, the liquid will start rising. Hello.
Yes.
The liquid will start rising. See, it's all in the diagram here. Okay. Now you see, I don't have it on Earth. The condition is same. Okay. The tube is also same. But now, as far as this is concerned, the surface tension forces are there. It starts pulling the liquid. It starts pulling the liquid up. It starts pulling the liquid up. Of course, as Arun said, okay, we'll have the liquid here. That's what we'll have. Fine. Okay, I'll go. We'll have the liquid. So now what happens? The liquid will start rising. The liquid will start rising, and now this is in elevator. Elevator, which is freely falling. Okay, then the liquid will keep on rising and it will come up to this level. Hello, got it? Hello, got it? Now, further it cannot go beyond. Why? Because there is no additional glass surface here to pull. It has come to the point and there is no other further glass surface to pull it. Got it? So the liquid will stop here, it will not come out. The liquid will stop here, it will not come out. So now you see the height to which it will rise from this point to this point will be what? Will be 30 centimeters. So if this experiment is conducted in freely falling elevator, the length to which the water column will rise is 30 centimeters. That's the physics. And see, in NCERT book this is given. What is given there? Supposing you have taken this tube. Supposing you have taken this tube in the first experiment. It is raised to 10 centimeters. Supposing I cut this tube here at 5 centimeters. So what will happen? Will the tube start working like a fountain? Then, what happens? You can start drawing water from the well without using any pump. So perpetual energy, it is not supported. First of all, you can directly argue like that and say, well, if I cut this tube here, see, but for this it would have risen up to 10 centimeters. If I cut it at 8 centimeters, now the excess water will start falling. No, it will not happen. Because one is perpetual energy, it's not supported. But now if you go by the theory here using surface tension, see, there is no additional glass here to pull the water and therefore it will stop at 30 centimeters. Did you get it?
Yes, sir.
Right. What other?
If the lift is moving down with some more acceleration than this, sir.
Okay. Good thinking. It is going down with more acceleration. Then what happens?
So it should come out.
In that case, you see, this is a very peculiar situation there. Okay, so if you go by this formula, then the acceleration should be negative. Acceleration should be negative means what? Okay, then there should be a force which is pushing it up.
Yes,
Then obviously it will come out.
yes.
You can take the
process will readjustment.
Pardon?
There will be readjustment of the process.
No. Adhesive forces will be there. Adhesive forces will be pulling. In addition to that, there is a force which is pushing it up.
Yes, that case,
That is why it will come out.
it may or may not come.
Why? It may or may not come.
And they drops it. There is some extra force acting.
See, now, because of the surface tension, it has come up to this point. Okay. Now, if some additional force is going to push it up, then it will come out. Surface tension said नहीं, उसके आगे मैं pull नहीं कर सकता. But किसी ने धक्का दिया तो it will come out. Obviously, it will come out.
Yes, sir.
Hello, Arun.
One surface and tension again attract itself while coming out.
So there are two things here. One is, if something is pushing it here, so what happens here? This will try to come out. So this will try to come out like this, and then what happens? The surface tension forces will do ulta like this. Okay. So now it depends upon how much is this push and pull and etc. All those things. Yes, you are right. It will first become convex, and then if still the force is there, it will come.
Yes, sir.
Good question. See, this is how I want all of you to learn. It's not just solving one problem and saying, okay, I learned physics. No, you have to ask questions like this. I have to ask questions, and we should all deliberate. Water rises to a height of 16.3 centimeters in capillary, of height 18 centimeters above the water level. Okay, if the tube is cut at 12 centimeters. Tell me, what is the answer? Now all the theory I have explained so far. I explained enough theory.
What will price of
12 centimeters, that's all.
Nice.
That's all, because 12 centimeters, just now I explained on that. So B is the option. B is the option. Okay, got it?
Yes, sir.
Okay. Now it is 9 o'clock.